Hello, my name is Vincent, and I'm a graduating senior at CSU Fresno with my bachelor's in computer engineering. My research project focused on building a scalable backend system and data pipeline for digital twins, machine learning, and visualizations for agricultural systems. So I was hosted at the UC Merced Parallel and Distributed Systems Lab with our lab director, Dr. Liu. The research project that I worked on was led by Adam Weingram, who was a PhD student under Dr. Liu. At the UC Merced PATSYS lab, we had on-site clusters and data centers, as well as an on-site experimental farm to generate sensor readings and to take drone images. This farm grew a variety of different grasses, and to the right I have some NDVI footage of the farm taken by a drone. So why are we pursuing this research? So digital twins and machine learning can offer a unique path forward for agriculture. So a digital twin is a digital model of a complex real-world system that uses real data gathered from that system. The advantage of a digital twin is that you can create hundreds of digital twins. And you can tweak different parameters, run different data, run different simulations on each iteration of that twin. This is really good and really important because you can do a lot of things such as, track farm health, analyze your farm operations. This will all help farmers make more data-driven decisions to increase their crop yield. They can experiment with different techniques, and it'll also help them avoid any unforeseen problems. Machine learning comes into play when we use machine learning to predict different outcomes, such as weather changes or anything relating to crop health. We can also use the digital twins to train our AI models, which will then feed back into our digital twins to create this sort of circular learning experience. So our goal for this summer was to build a digital twin of an on-site farm and integrate machine learning to predict future conditions. I served as the data visualization team lead, solving the problem of our data storage array, which consisted of heterogeneous data from a lot of different sources. This is a huge problem for all the different projects going on because we have inconsistent data retrieval across all of our different projects at the PATSYS lab. And there's no easy way to interface with this data storage. And going along with that, there's no easy way to view and visualize what the data that you want looks like. So my team's goal was to build a library that's capable of listing, retrieving, querying data sets in this data storage array, as well as building a backend with an API to handle user requests to retrieve data over an IP connection. So some capabilities of the API, of the backend API, was to have some query capabilities. So you can query by date range, date fields, anything else that you would either want. We also have some microservices on the backend that help out with data retrieval, as well as data primitives that offer a abstract way of viewing our data to make sure we can query the correct parameters. In addition to this, we had to build a query engine that is supporting these API calls. And then also, we were responsible for building a front-end web dashboard to very easily view the retrieved data. This is going to be coming into play with graphs, plots, and raster image viewers that's come from our drones. So for the backend side, we have our data storage array that contains the raw data files, the backend library, which handles the API calls, and then the various different projects that are going on at the PATSYS lab. The backend is designed around abstract data primitives, which are just generic representations of data that we can use to query what we want. So I have an example here for a table primitive that is just a generic representation of tabular data. So as you can see on the right, we can have the date, time, CO2 flux fields, as well as all the data below it. We can then use this to query, based off of date range, based off of CO2 flux measurements. So here's a diagram of how the flow kind of works. You can see on the right side, we have these different projects that are making different API calls that are being handled by the backend. that's then taking those API calls, retrieving the data from the data storage, and then it'll return a response to all the different calls. So for the front end that we were making this summer, I was serving as a team lead, where I focused more on project management and mentoring our younger team members, things relating to Git workflows, JavaScript coding, as well as the architecture of the project as a whole. And I also did some work to connect up their front end to the back end that I was building. So as you can see on the right side here, we have a whole bunch of different graphs and different plots that can visualize the data in different ways. The goal is to make this all user configurable, so anybody can build their own dashboard as they see fit to best visualize the data that they want. So why is this project important? Well, after the summer, we now have a comprehensive API that can make consistent data retrieval across all different projects going on at the PATSYS lab. As you saw earlier, we have projects with the machine learning, we have digital twins, we have visualization stuff, as well as benchmarking. So in addition to that, we also have a proof of concept front end mockup that shows the capabilities of how you can view and list your different data sets. And the future plans includes opening an open source project for the backend library so that others around the world can use the project or improve upon it. So in the end, I just want to give a thanks to Dr. Liu and the UC Merced PATSYS lab for hosting me. I want to thank Adam Weingram for giving me great mentorship and giving me a lot of leadership opportunities this summer. I want to thank the Ag8 team for their hard work behind the scenes, always being a great support for the interns and really a well-structured internship program. I also want to give a thank you to the NSF and USDA NIFA research grant that gave the opportunity. Thank you.